Hello and welcome. I'm your host Ruby Gill, and I feel honored to welcome you all on the behalf of lovely professional university. So attendees, what do you think the essence of today's webinar? Well, I'm glad to share with much excitement that today our expert will deliver his expertise and make us learn and know about how to program a basic robot, Firebird 5th. So I'm sure you are as excited as I am. So kindly allow me to introduce our experts. I humbly welcome Professor Rishi Chopra, Assistant Dean, School of Computer Applications, lovely professional university. A very intellectual personality who is very instrumental in research when it comes to education. Having 20 years of teaching experience in UG and PG level, he has guided many master's projects. Apart from being an academician, he plays a major role in administration as project head in Division of Admissions, lovely professional university. To his credit, he has conveyed 200 plus career counseling, motivational sessions, and seminars at various organizations of repute. He has organized numerous specialized technical events and part of so many conferences worldwide. So, sir, it's a privilege to have you on board with us today. Thank you so much for joining. Furthermore, we have with us Dr. Manmohan Sharma, Professor, School of Computer Application, lovely professional university. His expertise lies in wireless network, cloud computing, robotics, and robotic process automation. So, sir, thank you so much for giving us your valuable time today. Furthermore, I welcome our admission expert, Dr. Tushinderpreet Kaur, Professor, Mittal School of Business and Coordinator of CEL, Department of Counseling and Admissions, lovely professional university. Doctorate in Economics, MPhil and UGC NET qualify. She is holding an experience of more than 15 years as an academician. To her credit, she has more than 40 research papers published in referred national and international journals of repute and also authored one book. In addition to this, she has chaired various sessions and acted as a resource person for numerous seminars and conferences. And attendees today, she'll give you an insight of eligibility, fee, and scholarship, which I'm sure will make you save a lot of money. And in addition to that, she'll also be discussing about the infrastructure part of the university. So thank you so much, ma'am, for joining us today. So with this, I welcome you again to the webinar and looking forward for a great interactive session. So over to you, Professor Rishi Chopra, sir, for the content of the day.
So let me discuss. First of all, I would like to thank Ms. Ruby for such a wonderful introduction of mine and of course Dr. Manmohan. And most of the time, Dr. Manmohan is going to take up this session. He's going to let you know the basics of robot. He'll talk about the sensors. He'll be talking about the movement of the sensors, how to train a robot through an interface. Everything will be covered by him. And I'll be majorly responsible for discussing few of the programs and a little bit of your future. So I would request Dr. Manmohan to take up his part first of all, which is the major part of this presentation. And then I'll be appearing for another 5 minutes to discuss your future and what all programs that we offer. Over to Dr. Manmohan.
Thank you, Professor Rishi and Ruby Man, for providing me the opportunity to present my skills here. And thanks for the very good, very warm welcome speech here. Thank you. My screen, my presentation is visible? Sir, my presentation is visible? Okay. So we are going to start with this very little thing. I just tell you, I just show you the picture of the robot which is available on the presentation also. Okay, and I show you that robot also. So here, this particular robot is actually the Firebird 5 robot. You can see it, the Firebird 5 robot. You can also see it here. Is it visible? So this robot, we are going to just work on this robot with some small programming with that. And we have just started with some basics of this robot, some part of this robot, and then start with the little steps so that you can learn about the proper programming environment. Okay, and so we will start with this. So Firebird 5, actually it was developed as a robotics research platform, which was developed by the IIT Bombay, and for that it was developed by a company named as Next Robotics. So Department of Computer Science and Engineering of IIT Bombay used this for their research in the robotics. So here different controllers, microcontrollers are used on the with the Firebird, this Firebird 5 robots at Mega 2560, which we are using right now. Okay. Second, P89V51RD2 8051 robot. This is what we are using to program it. Okay, to send the program inside the robot chip. And there is another chip which we can use instead of P89V51RD2. This is LPC2148. LPC2148 ARM7. And this because this is a research platform, so you can add a lot of your own custom designed microcontroller adapter boards on this platform. Okay, so let us start with the some building blocks of this robot. So this robot is actually working with some sensors. Okay, these sensors are used for sensing the environment condition and different types of things, like what is the, if any obstacle is here, okay, in front of that robot, then it will sense that obstacle. What is the distance of that obstacle from the robot sensor? Okay, and then we can also sense it can also sense the white line, so that it can follow a particular line. Okay. Similarly, there are some actuators we are using in this robot. Actuators are used for the movement of the robot and its part. Like it has some wheels in it, so you can use how wheels are moved and how this different arms, and we can add arms to that robot, and then these arms can be used, just like you can see in the picture of the image, this slide. So you can move the arms, and then we have to perform all these functions of the robot. We use controller or processor. In this controller and processor, it works as the brain of the robot. Okay? So here we are using this brain of the robot for performing this activity. So here we can say that it gives you a very good exposure to the world of robotics and embedded systems. Now another thing is which is available in that robot, it is the intelligence. That means we can add some commands to it, and then it will perform according to our expectation. Okay. We can write some commands. So we are going to work on that. So we are creating the program for that. For providing the intelligence to that robot, we can use embedded C for that. Okay, and it's not very difficult one, because it only used the programming of the pins. Every chip has a pin. I think all of you are aware about that. Every chip has a pin, and in that pin, you have to just program that particular pin to perform a particular function. Okay. Now, for obviously for working of the robot we need power. And finally, what is the purpose of the intelligence and the command which we have write in the which we can feed into the robot? We want these robots to communicate to each other. Okay? So how to feed it? We can feed the commands or programs into the robot, and then the robot will communicate in a particular manner, in the manner which we want to make it communicate. Okay. So these are the various building blocks of the robot. Now let's, because most of the work is done by the sensors in the robot. Okay. So we look at the sensors; those are used in it. Okay. So first of all, we are using AVR architecture-based adapter board in the robot. This is available on the top of this robot. You can see it here, visible. Okay. And second thing, we can use a microcontroller that is which is Atmel based at Mega 2560, which is work as a master controller for all the activities, all the programming. Okay, and now here we can see the sensors, and those are available on the Firebird 5 platforms. Okay, so we start with the Sharp IR range sensor. Sharp IR range sensor, IR means infrared. Okay, here we are using infrared LEDs as the transmitter of these activities or these data. Okay, and you can see a picture of this IR sensor. Okay, it received the signals from the different or different objects, and then it sends it and then read it from here. So this is the IR light, and then it reads from here. Okay. Once it reads the data, it performs some function on the basis of that. Okay. So depending on that, it will just use to identify the obstacle, means any object in between the path of that robot. So here you can see there is working of that particular sensor. You can see here, this is the robot, okay, and this is your IR LED. So lens, this IR light just is fed off, and then it will be reflected from the object, or scattered. We can say scattered from the object. Okay. So once it is scattered, so where at this particular position sensitive IR detector, where it incident on the IR detector, okay, using that position, it just identify the distance. Okay, it just identify the distance. How it identifies the distance? You can see from here. Sorry, from here at this point to that particular point. Okay, we have a distance of this. We can measure the distance of this line. Okay, the point at which the ray, this reflected ray is incident, and the point from where the light is emitting. Okay, and we are using the Pythagoras theorem for that. Simple. A square plus b square equal to c square. You can easily find out, and then we can find out this this particular range, and we can identify that what is the distance here. If we know this distance, we know this particular angle, and then we can easily identify the distance of the object from the IR sensor from the room. Okay, so this will be used for identifying a particular object, and it measures that whether the object is near or far or very far. Okay, I just add one video in that which we did one experiment related to that, how to find out that whether the object is near or far from the IR sensor. Okay, so so here you can see when the object is far, the incident point at the IR detector is near to the IR LED. okay, near to the higher LED. So this point, this particular position will be detected by this higher sensor. So here we can say that what is the bad range at here or good range of the object. The range, if your object is within that particular range of the diameter of the robot, then we can say it is in the bad range, and when it is somewhere more than out of the diameter of that robot, then we can say the object is in good range, so that it can calculate that object distance. Okay. Now this is the video which you can see, and this is what it shows. We place some obstacle. The robot is there, and we place some obstacle here at different positions. So this is at 40 centimeter. Then next is placed at 70 centimeter, and there is one more. Okay. So here you can see these three objects are placed, and when it shows us that, I think it is visible to all of you, that obstacle is near. The first obstacle is this one. When it is removed, you can see that it sends that the obstacle is far. Okay. When the third object is removed, it shows that obstacle is very far. Okay. So this is the work of IR sensor to find out the range. What is the distance of this particular object, a particular object. Okay. So now, so IR sensor is used for detecting a particular object, obstacle in the path. Now next is the IR proximity sensor. Okay, what is this proximity sensor? Proximity sensor just identify that is there any, what is the direction, in what direction that obstacle is available. Okay, when it moves, if any obstacle is there, it will stop. Okay, so it just identify or judge a particular obstacle in the path and then stop. So now it uses an IR LED, same infrared LED, and the receiver is a photo transistor. Okay, and here on the firewall board you can see these are the various I think 5 or 8 proximity sensors are available here. Proximity sensors are used on all the sides because we can move the robot anyway, in any direction. Okay, so there is your proximity sensor. Next is the white line sensors. White line sensors are when you look at this robot. I can show you this in the robot also, where you can find out this. Is it visible? So at the back side of this, you can see this one is your, this chip is used, and this one is your white line sensor. Okay, so it emits the light, IR light. Okay, and then it receives the light reflected from the surface, and then it just read that whether it's a white line or some other color. Okay, so this is the way we can find out that what light we are using. And here this particular there is a wheel which is used, master wheel, for moving the robots on a particular line. Okay, so let's move back to the So now, when we are working on this white line sensor, what we are trying to do, we are just trying to uh, move the robot on a white line. I can show you this white line here. Yeah, you can see on the table there is a white line is there. So we are using this particular space for using this. Is it visible? So, okay. So this one is used for, hello. Yeah, this I think it's visible now. So this one is used for doing this experiment for the white layer sensors. Now, so how this white line sensor works? Here you can see this. This is the wheel, and these are the two white line sensors. Okay, one is for the white line, and second one is the photo transistor. So IR light emits the red light on the surface. Okay, so every light is when it incident on the surface. Okay, there is some reflection from that. Okay, so reflection is in the form of some other type. So whatever the color is, okay, that will be reflected and it will be read by the photo transistor. Okay, it will be read by the photo transistor. So when the LED light, this IR light emits the light, red light from there, it it sends that particular color, and then this then give the information to the photo transistor, and from the photo transistor this information will pass on to the sensors or to the robot, and then we can use it for performing this operation. So here you can see the same position. One is the white line as well as the proximity sensor. This experiment is performed on this video, these two. Okay, so see, the robot is following the white line in that, and it stops when there is an obstacle in between. See, so when obstacle is moved away, again it following the white line, and then it stops when it forms the obstacle. So this is the experiment which we did in the to show the work of the proximity sensor, the white line sensor. Okay. So we set it to the when the obstacle is near, then it is stopped. So this experiment can be mostly used in the traffic for the cars, where you can put these sensors in the cars. You can see there you can heard there are a lot of sensors are used in the in the cars to whenever some obstacle is near to it, it will just stop or start some beep sound. Okay, so that proximity sensors. Now next is the position encoder. This position encoder is used to identify the position of the wheel at a particular place. Okay, so how much? So you can see here in the wheel, you can see there are some grooves are there. In plate is there with the grooves. Okay, so here at this point you can see a chip. This is position encoder that encodes the position of that wheel, that how much rotation it already performed. Okay, so this one is this position encoder is used to identify that how much distance is covered by the wheel at a particular time. So this is position encoder sensor, and you can see the position encoder sensor that using the position encoder we can find out that what is the velocity of uh, that particular wheel. Here in the robot, both the wheels are working different from other. Or both the wheels have their own motor. Okay, so you can see this here. This wheel is available. You can see there are two motors are available for each wheel. One is this, and second one is this. And these are this is the plate, and below that you can see the position encoder available inside. This chip is below. Okay, so that position encoder chip is just to read the information that how much distance is covered, and then pass it to the robot. Okay, clear? So let's see a video that how this will calculate the speed of this wheels. So there's a video about that. You can see the current speed is 0.0. They start. The wheels are not moving. Okay, now the speed, we increase the speed to 63. Okay, so here you can see when we have the 63 speed, the wheels are moving very slightly. Okay, so how fast a wheel can move? How fast a wheel can move? We can set that also. Okay, so now it's 126. Then the speed of wheels are moving fast. Then we increase the speed by double, it becomes 189. Wheels are moving more fast. So there is one experiment that will be used to create these to speed up the wheels. So here both the wheels are working simultaneously now, but we can also make them work differently. We can stop one wheel and move one wheel. This we can also. You can see this in the next experiment which we are going to do in the. So now the speed is going down. Now it's and it becomes 0. Okay. So there are a lot of other sensors are also used in the firewall. One is the infrared PSOP receiver, and servo-mounted sensor pods which we can use in that. Then accelerometer, gyroscope, ultrasonic sensors, motion sensors, global positioning systems you can use with this. How to power it? So I have you can see this is the battery of this one, and here I show you this. This is the adapter, power adapter which we are using, and where it is placed. So how to give the power to the robot. There is the robot in my hand. Okay. At the back of this robot, is it visible to? I think all it is visible. Okay. You can see there are two types of powers we can provide to this robot. One is the battery power, this one, and second one, this is the auxiliary. Okay. So we can provide battery power to charge the battery. We can insert this socket here and I put this in the socket. It starts beeping and a green light is visible here. Okay. Is it visible to all of you? Okay. So when this green light is visible, your robot is start charging. Second is if you are not if you don't want to work on battery power, then you can use the auxiliary power also. Once you start this with the auxiliary power, your robot starts working. This is the program. Okay, this robot starts working, and it also. So here's the way your robot will start work and you can do a lot of things with it. So here we are using a 9.6 2100 mAh battery with this in this robot, and second one we are using auxiliary power 12 volt 1 ampere adapter. Here to open this, you can see the battery is available. So we can cover up the battery. We can just put the battery here, place the battery, and then our robot can start work. And there is a button here. On-off switch is here. Okay. And if I want to work on the battery power, I can switch on this to the battery power, and then it starts working. Okay. So this is how your robot can start working. Now, in the slide presentation, you can see the block diagram of this Atmega 2560 based robot. So here, these are the various different sensors and the component of this robot. All are connected to Atmega 2560 microcontroller, and this will be used to control the activities of this robot. Complete activity of this robot. Okay. Now, move to the next slides. The important thing, which is really important for the programming, that how the robot communicates, how we can feed the program into it. Okay. So ports, here we are using different ports. Actually, your Atmega 250 chip. Okay, it is a chip that will be programmed. Okay, and we are just using the different ports where we can connect the peripherals. So the peripheral devices, those can be connected. These are the input devices, that is the switch, sensors, buttons, etc. Then some output devices are there: buzzer, LED, LCD, etc. So here on this one, I show you this. You can just look at it. My screen switch. Okay, so here you can see this is the robot, and on this robot you can see there are a lot of different input and output positions. First, This is your position to input to connect a peripheral, to enter the program into this, to feed the program into the robot chip. Okay. This complete chip is your Atmega 250 chip, which is available on this. And here you can see these LED lights are connected to this. Okay. This LCD is connected to this. Okay. The buttons are connected to this. There are there is some input board connector is connected to this. And here you can see these are the in, input interfaces, okay, where you can connect the different keyboard or mouse. Okay, here you can see these are the proximity sensors are connected. One, then there is two, then there is three, then there is four, okay, five. Then on the top of this, you can see there is your connector, okay, IR sensor for the direction, and then there is, and these are the proximity sensors connected here. And to make these to connect these input output devices to feed the program, we have this adapter available here. This adapter. This is your adapter which we are using to insert the program into the robot. Okay, you can connect this one adapter here, write the program into the PC, and from a USB cable, okay, here you can see you can connect like this, okay, and then we can use this USB cable and put this USB cable into the PC, okay, and this will be used for entering. Now you can see the light is started, okay. Now we can insert the program into this robot, okay. But before inserting the program, we learn some basics of the pins, how to program a particular pin, okay. Then we can start. So ports are there. There are different ports are available in the this robot, this 5x5 robot, and in Atmega chip, Atmega 2560 chip, you can use a 100 pin control. 100 pins are used, where out of 100, 86 pins are used for input and output. Okay? And these pins are grouped together to form a single port. So total ports, those are available in that Atmega 2560 are 10. So all these 10 ports are 8-bit ports, okay, and every port is denoted by port X, where X is A to F, that is A, B, C, D, E, F, H, J, K, and L. Okay, all these ports are 8-bit ports, and there is one 6-bit port is also available in this Atmega 2560, where the letter which denote this Atmega this 6-bit port is G. Okay. So we can configure all the port pins individually for input and output. So every pin, that means we can just program a particular pin, that whether it is used for the input, taking the input, or dealing with the output. Okay. So these ports are used, and using those ports, we need 3 different registers. What are these registers? These are the registers which stores the value of these ports, okay, and read or input or output for the value of these values. the port values. So DDRX is one port which is associated with it. Second one is port X, and third one is the pin X. Again, the alphabet denoted or represented X is A to H and J K L. Okay. So these three registers, remember these three registers because these three registers we are going to use in our programming also. Okay. Now, first one is the data direction register, which is called DDR, data direction register. So, how to define the port pin as input output? If we use the value of DDRX equal to 0, if a particular pin value is 0, that means this pin is configured for input. Okay. If the pin value of any DDRX register is 1, then this port X is defined as input. That means that particular pin is used for input. Okay. So like one example is given here. The port is D is defined by the 8-bit or 2 nibbles. I think all of you are aware about that, how that 8 bits are a combination of 2 nibbles. Nibble means 4 bits. Okay. So 8 bits are a combination of 2 nibbles. So we are working on the nibbles here. So these are the nibbles, first nibble, sorry, and the second nibble. Okay. So we can define the lower nibble of the DDR-B as the input and the upper nibble of the DDR-B as the output. So input means the pins are 0, output means the pins are 1. Okay, the value of the pins are 1. So in that all these values are there. So lower nibble is 0, that means this particular DDR-B lower nibble is used for the input and upper nibble is used for the output. And now this complete arrangement is represented in form of hexadecimal number system. Okay. So where the value of DDR-B is now 0x. 0x is used, it is prefixed with any hexadecimal number. That means whatever the number is, it is an hexadecimal number. So we use 0x F0. F 1 1 1 1. 1 means 15. 15 for 15 we are using. The hexadecimal value of the 15 is F. Okay. And for this it is 0. So F0. So for F is represented this complete first upper nibble and second nibble is represented by 0. Okay. Now second register is pin X. So pin X is used for reading the data. Those are presented on a particular port and save the value of that port in the register. Okay, value of the register in a variable. Okay, value of the register in a variable. So it reads the data from this port pins and then store that value in a variable. Okay. So one of the example is given that data on port C pins are given as 1 1 1 1 0 0 0 0. It is just like we have that upper nibble is all set for the output and lower nibble all set for the input. Port C value is this. So it read the pin value as pin C as 0x F0. 0x F0. Okay. Now port X register, third register is the port X register. So there are 3 different cases. One is the case one where port X is defined as output. So purpose is to send the data present on port X pins. So example is given. This example is given that DDR-A are given as 1 1 1 1. All the pins are set. All the values are set to. All the nibbles are set to. Set as output. So DDR-A value is 0x FF. Similarly, port A value is 0x FF. Okay, that means port X is completely defined as output. Similarly, case 2 is when port X is defined as input. So input, when it defined as input, that means what we are doing, we are just activating or deactivating the pull-up registers, which is available on that chip. So port X value, if port X value is 0xFF, that means all the pins are activated for pull-up. Okay, so it activates pull-up on all the pins. So we can read the data from those pins. When port X is equal to 0, and deactivate pull-up on all the pins, we cannot read. Okay, so here when we define this DDRA as DDRA 000, that means it is 0x00. Okay, so that means your DDRA is not activated for the pull-up. But when the value is 0xFF, that means pull-up activated for all the pins of port A. There's one example is given. So here we can make the port D as output port and send hex value D5. D5 means 0x D5. Value of D in decimal is, what is the value of D in decimal? It is 13. Okay, so we start with this. It make the port D as output port. So we all the value, all the tables are 1. So this becomes 0xFF, and put data on port D as D5. So D5 is where first nibble is D and second nibble is 5. So 13 is 1101 and 5 is 0101. Okay, the binary values, binary equivalent of D is 1101 and binary equivalent of 5 is 0101. Okay, so this is how we can define this. So all these things are there, and now we are working on a particular program that work on this direction. So we have this particular robot. It moves in different direction. We can program it. So this could be a direction forward is there. So value is like this. That left value EA0 is 0. Left forward is 1. Right forward is 1 and right backward is 0. So here we are dividing into left backward, left forward, right backward, and we put the values like this. If we want to send the robot in forward direction, okay, move the robot in forward direction, then the value is 0110. When we move the robot in backward direction, then what will be the value that in reverse? Left backward is 1, right backward is 1, and left forward and right forward is 0. So it becomes 1001. Okay, so we start with a program. I just start the Actuators Studio, which is the software which we are using for start it. This Actuators Studio is the software that we can use for performing the different for embedded C program. So I'm opening this. Let's see where. And we are going to write a simple, very simple program. Okay. The program is based on the movement of the robot. This one is open. It will take some time. Let me open it and then we'll make it. Just a minute, Ruby. Just I'll show them Actuators Studio. Okay, So I think it's visible to all of you. This is Atmel Studio program which we are going to use. So here I already write a simple program. Whenever you start Atmel, it will gives you all the necessary functions in it, and you can start working on it. So this is the experiment which just move the robot in S shape. Okay, so it's a very simple program where we are going to configure all the motion pins. So here all the motion pins, here all the DDRA values are set as output. So all the direction pins are set as output. I think it is visible to all of you. Then second, port A register where all the initial values are set to 0 because we want to enter some value in it from the sensors. Okay. Then DDRL, it's a register which is used as for the PWM register, which we are not going to use right now here. So we are going to this. This is the function which is used for the forward. Move the robot in the forward direction. So the initial value of this code is that all those pins, those are rotated both the wheels forward. Okay, rotate all the wheels, both the wheels forward. So in that case, your left wheel and the right wheel both should be 1. Okay, so here we are creating this and we are using this 1001. Okay, now next is sorry, it becomes 0110 because both the wheels should be forward. Left, the value is 0x05. Similarly, we can set all the values like this, and then here we are using a very simple concept that first we forward it and then forward it for a particular time period. So delay is 5000 milliseconds. This is in milliseconds. Then it is stopped. Delay is 500 milliseconds, and then it turns left. Okay, and then there is a delay of 680 milliseconds, so that it will turn 90° towards the left. Okay, then it is stopped. So this and then for after 500 milliseconds it move forward. So for 2500 millisecond it move forward and then is stopped, and then for a delay of 500 milliseconds it stopped and then move left. Okay, once it moves left, it moves. There is a delay of 680 seconds. That means it moved till the robot turn to the 90°. Okay, similar values are used here, and then we insert this main function and then run this. So it travels the S shape. Okay, so I am going to show you this. So you can see this in my second can. Jatin, can you start it? So it will create a S shape. So it's a very simple program which we have created. You can also understand this. So now it completely take a complete S shape and then start. So this is the program, and I think if you want to learn more about this, you can contact us for that. Thank you. over to Ruby and Rishir. Thank you.
Thank you so much, sir, for intensifying and magnifying the knowledge of our attendees. And after this, I'm sure attendees will be proficient in how to design a robot and will sparkle with this kind of great experience. So thank you so much, sir. And now we have our admission expert, Dr. Tushindar Preet Kaur with us. So ma'am, over to you for the admission part of the university. And after ma'am concludes, we'll take a few queries from attendees. So over to you, ma'am.
Thank you so much, Miss Ruby. Can you please share the screen sharing rights?
Yes, ma'am. Please give me a moment. Yes, ma'am. Over to you.
I hope my screen is visible.
Yes, ma'am, it is.
A very good afternoon, one and all. I'll be speaking about the rankings, the campus life, infrastructure, fee structure, as well as the scholarship. It gives immense pleasure to share that 13 students of lovely professional university, they not only participated, but they won different medals in Tokyo Olympics 2020. Story doesn't end there. The university also lifted top trophy at Khelo India University Games and won 51 medals. Now I'm going to speak about the rankings. World University with Real Impact ranking has ranked Lovely Professional University as second in India. The Impact ranking has ranked 74th globally, and the World University ranking 2022 has ranked university as the 36th among top universities of India. It gives immense pleasure to share the university has been ranked third in the Atal ranking of institutions on innovation achievement. And last but not the least, NIRF has ranked our university as 47th among the government as well as the private universities in India. Now I'm going to speak about the campus life as well as the exposure offered. University proudly hosted 106th Indian Science Congress, which was inaugurated by Shri Prime Narendra Modi ji. Nobel laureate for peace visited university and graced the convocation. This is a glimpse where you can have the look of president of two countries gracing the convocation at LPU. We do invite your entrepreneurial ideas. We do have the startup school, which was inaugurated by late Shri Arun Jaitley ji. He's world-renowned life coach Gaur Gopal Das, who visited the university and inspired the students how to lead a happy life. Apart from the great leaders, the university has also welcomed the celebrities. So glimpse of the Shah Rukh Khan and Deepika Padukone, who visited the university and interacted with the students. Captain Mahendra Singh Dhoni also visited the university and interacted with the students. Now I'm going to speak about the infrastructure. This is a glimpse of the amphitheater, which is used to organize the cultural events, competitions, Nukkad Nataks. This is a glimpse of Shanti Devi Mittal Indoor Auditorium with a seating capacity of 2,200 people. This is the heart and soul of the university. You will find all types of shops ranging from stationery to lovely sweets. This is a glimpse of Central Library with a repository of more than 20 lakhs book. To bring you out of the academic monotony, we have the bowling alley. Yeah, this is the glimpse of the gym facility. We have world-class gym trainers. We do care about your health. We have 24/7 medical facility. We do have a hospital where experts visit and they provide the consultation. Yeah, we do have the one big indoor stadium with lot many facilities, swimming pool, all weather, badminton courts, shooting range. This is the day view of the university. This is the night view of the university in general and the boys hostel in particular. Now I'll take you through the website where I'll be talking about the fee structure, eligibility, as well as the scholarship. The website link is lpu.in. Therein, you need to click the second tab, that is admissions. After that, you need to click on admissions. Then you need to click on the specific discipline in which you are interested. Like you are interested in MCA. I'm going to speak about the eligibility. It's 60% plus LPU Nest. LPU Nest is the exam which serves two purposes, eligibility as well as the scholarship. So better you perform, better will be the scholarship. I have already talked about the rankings, the curriculum highlights you can have. Moving ahead with the program fee, it's clearly mentioned 80,000 per semester. We do acknowledge your hard efforts, either in your previous qualification or last two previous, whichever best will be there, we will be providing you that scholarship. Over and above, we are taking your LPU Nest as for the scholarship basis as well. So whatever best will be there, we will be making it applicable for you. So in one liner, the scholarship slab ranges from 28% to 48%. So you can have a look where you land and which slab will be applicable to you. So further scrolling more, I can show you, I have talked about scholarship on the basis of qualifying exam, on the basis of LPU Nest. We do have other scholarships, innovation, startup, sports. If you have any documentation with you since last previous 2 years, drop the pic of that document to us at admissions@lpu.co.in. You will be getting a reward from our counselors. Then we do have the financial aid. So you can check need-based scholarship is there, then certain disability, then defense. So you need to drop a glimpse of this particular certificate for these at admissions@lpu.co.in. So by scrolling more, I am pretty sure you might be having this point into your mind that what is the process. So first step is you need to sign up. Then you need to apply university's exam, that is LPU Nest, which serves two purposes, eligibility as well as the scholarship. You need to book the exam slot. Once the exam slot is there, then you will be getting the result, and by God's grace, once you clear and you score good scholarship, you will be moving ahead with the admission. Last dates are also mentioned, but I'll advise you not to wait for the last date and plan your decision, freeze your decision well in time. If you have any query with you, these are the tabs through which you can connect us. We are there on WhatsApp. You can check LPU in your town. Our counselors are there. You can also schedule a call. I'll advise you to go ahead with 360-degree view. Last but not the least, we are also available on live video counseling, where one-to-one counseling will be done. I'm pretty sure you might be having that, how we are going to get these informative sessions. We are taking this series of sessions, so you can have the access at LPU's Edu Fair. By clicking on this page, you will be getting the input for all the previous webinars which have taken place and all for the upcoming webinars. So if you have not registered for that webinar, I'll advise you to register yourself for your interested webinar, either by clicking on the registration link or by scanning the QR code. So identify your area and book the webinar and register for the webinar. You can also see the YouTube recordings in the past webinars. So on this page, I talked about the fee structure, eligibility, scholarship, different ways of cracking the scholarship. So last but not the least, you can visit us, the details at lpu.in. You have any query, drop a mail at admissions@lpu.co.in. And plus, you can also get to us at our helpline number 01824 517 000, 01824 404404. It's over from my side, Miss Ruby.
Thank you so much, ma'am, for the detailed information about the admission process. And I hope the attendees must have got the route from where they can get all the information about the admission or to approach the university, plus the infrastructure of the university. So thank you so much, ma'am. So with this, I would request Manmohan sir and Professor Rishi sir to please join the platform, because we'll take a few queries from the attendees. Yes, sir.
Yeah.
All right. So, So with your permission, can we take up those queries? We have few queries from the attendees.
Yeah, of course we can get.
All right, sir. So there is a query from a student named Tanzan. He wants to know that how efficiently you have told us, you have demonstrated that a robot has been made, has been designed. So will students be allowed to design the same, or it will be facilitated, like assisted by any faculty, and they have need to only witness it, or they can put their hands on this and they can practically make this robot by themselves? So what is your take on this, sir?
Ruby, can I know the name of the attendee who has asked this
So
question?
Tanzan wants to know.
Nelson, definitely this is a very nice question asked by you. Definitely, we have a separate robotic lab for you people. It's not for us, it's for you. Those who are going to come over here, those who are going to choose the specialization of robotics, or they select a subject as a departmental elective. Definitely, we have a full-fledged lab with a lot of such robots, Firebird 5 available with us, with all type of assistance that is provided by many faculty members and lab technicians headed by Dr. Mohan over here. He is the in charge of this lab. So if Dr. Mohan, if your camera is connected, and I hope you are sitting in the robotic lab, if you can move into your camera and just show the lab and few of the available facilities, that would be really helpful.
Sure, sir. I'm connecting my camera.
I know you need to manage with another movable webcam. Definitely
Yeah.
that would. But we to give you.
I'm using my another
Yes,
camera.
we can get into that. So you see, Nelson, a lot of facilities. Other than this, this is what you are watching is a robotic lab. You see a table in between, which is marked as the points, wherein the robot is going to follow those points according to the algorithm provided by you people when you program the robot. So you see a rack around there on the left corner. I see a lot of robots lying over there for you all. Yes, they are definitely available for you.
I am
Similarly,
just
similarly, we have a digital lab. Uh, Fortunately, I'm sitting over here in the digital lab where we have all the kits available for you, um, wherein you can make your own circuits. So you can see a live thing wherein the robots are there. You plan yourself and get into this. This is a very interesting subject. When you come over here, definitely you can take up these specializations if you are interested in. Over to you.
Definitely, sir. This is a very wonderful experience which we are witnessing over here. And attendees, you'll witness the same in person when you'll come to the university. So don't wait for the dates, last dates. Just take the admission as soon as possible. So we'll take up another query. So this is, I believe this is a follow-up question from the attendees that what you have just discussed. So there's a query from Shubham Kumar. He wants to know that in which semester or which course, sorry, year we'll get to know, we'll learn about this. Will it be in the last year, or we can do this from their starting year? So can you please clarify that from which semester they'll know, they can get to know about this or learn about this?
So normally, if you are graduating from here from the third semester onward, we try to use specialization such pathways wherein such subjects are going to come your way automatically. There is a our curriculum is flexible. You see, we offer so many pathways. If you get into databases, or you get into programming, or you get into networking, when you select one of the pathways, then yes, surely within that pathway, these relationships automatically will come to your scheme, and you will be studying these from the third semester onwards.
Okay. Thank you so much, sir. Thank you so much, sir. Manmohan sir, would you like to add something to this?
I just want to add something in this. Actually, as Tenjin asked us that whether we are going to work on these robots or not. These robots are for the students only, not for. And here you can work, and here you can make your programs and do the activities to learn the robotics. So it's up to you that how much you want to learn. Okay, and you can learn a lot of this because not only these this is one module available here. Okay, there are a lot of actuators are available with us where we can create different types of robots, different types of experiment on this. So we are looking forward to it that the students will come and uh, do work on these robots. Thank you.
Thank you so much, sir. Thank you so much, Professor Rishi. Thank you so much, Dr. Manmohan, for resolving all the queries for attendees. And with this, we'll conclude today's webinar. So thank you, attendees, for sparing time and participating in today's webinar. We appreciate you all for being here, and I believe your knowledge has been enriched by today's webinar. Also, I would like to express my appreciation to the experts for their valuable contribution to the today's webinar, and thank you so much, sir, for demonstrating such a wonderful thing that I haven't witnessed ever in any webinars. This is such a unique webinar in all senses. So thank you so much, sir. Your years of experience, your years of research will definitely help the audience to choose the right path. So until next time, I, Ruby Gill, finally sign off the session. Thank you, everyone.
Thank you so much.